In your class, sounds like we left off here where we had found our means, right? So we had these 10 values, 5 without additive, 5 with additive. They'd taken them, they mixed them around, formed 2 new groups, right? Okay. And then with that, we found mean 1 and mean 2. When you look at these means, we then found the difference of the means. And I know I hadn't gotten it written down, but I think what we'd started to talk about was the idea that when you mix the groups around, with and without additive, okay, if the difference between the means is very little, okay, so if it's close to 0, what that's going to support is that, so if there's no difference in groups with and without the additive, the difference between the groups will be 0. So if the additive is not doing making much of a difference, not doing much of anything, then these means are going to be pretty close. Okay, and that's what this was showing. Okay, now it still comes back to, folks, this is 10 pieces of data, right? It's really a relatively small sample, especially when it's just 5 with and 5 without additive. Okay, but here we have a situation where they're very close. Now, in the next part of this, we're going to take these same 10 numbers and rearrange them again and see what happens. Okay, and again, if they keep coming up close to 0, that's going to say that the additive isn't making much of a difference. So that's what we're getting ready to look at. So make sure if you've written anything down you want here. As I said, my statement down there, if there's no difference in groups with and without the additive, the differences between the groups will often be 0. Okay. Make sure you guys have a moment to get what you need there. And then you can start looking at the next page. And I hope you guys have calculators. I expect you guys to do some of this work. We have several things to get done today in terms of calculations. So I hope you have calculators. Now, as you look at the next piece, okay, in one particular randomization, one group has these data values. So they've already taken and pulled the first group, okay? So they've taken, of the 10 values, they've taken and pulled one group, and I'm going to call this group 1. Okay, first thing, ask us to identify the values in the other group. So
at this time, we are all clear from our lockout. Again, we are all clear from our lockout. Thank you.
Are your rides good? Okay, if you need to go send a quick text, then do it. But okay, so they've pulled these 5 values already: 34.1, 36.7, 35.1, 36.1, and 36.8. Okay, what are going to be the 5 values left over for the other group? What can you guys tell me? And again, you're going back up to the original 10 values, yes? So what 5 values you got?
34.8.
He says that with a question in his voice.
36.8.
Okay, 34.8 is 1. 33.8 is 1.
36.0.
Okay. 36.0, or in other words, 36.
32.9.
32.9.
33.1.
33.1. Okay, so those are the other 5 values. And I'm going to call this group 2. Okay, so we have a new group 1 and a new group 2. Again, we're mixing them up, seeing what happens. So calculate the difference of the means for the 2 groups, which means we need to find our 2 means. So we need to find mu1, or mean 1, and we need to find mu2, mean 2. Okay, so grab your calculators, start doing the math there. As I said, I called group 1 the numbers they gave us up here. I'm calling group 2 the group of numbers we just wrote out. Is your stuff here?
No, Amber's in the stage room. She's gone, so my stuff's lost in her room.
Oh.
So she can't bring keys.
If you go to the office, they could probably get someone to let you in there.
Yeah.
Yeah.
Thank you.
Because you're gonna want your stuff.
Yeah.
Yeah. Or a custodian.
Yeah.
Okay. Are you giving me a mean, Logan?
I mean, I can.
Okay.
If you want something else, I can give you that too.
I'm looking for means. It's an interruption day. Okay, which one we going here?
I got a 1.
Okay.
I got 35.76.
Okay. And it added up to be
I got 178.8.
178.8. Dividing by 5 again is that 35.76. Okay. Mu2. What's my second group add up to be?
170.6.
170.6, and we're going to divide by 5 again, and this time we're getting
34.12.
34.12. Now, when we talk about calculating difference of the means, okay, when we have a specific group with the additive and without the additive, you're probably doing with minus without. In this, we have 2 random groups, so think bigger minus smaller. So that means in this case, it's going to be mu1 minus mu2. So 35.76 minus 34.12. And what do we get when we subtract those?
1.64.
Okay.
It's a much bigger difference than 0.08.
It is. It is a much bigger difference, isn't it? And remember, the idea is if it's close to 0, the idea is the additive's not making a difference. The additive's not doing anything. However, in this one, the difference is much different. So that would make you think maybe the additive is doing something. Okay, now, what do we have here? We had the original, which was 0.76. Okay, and then we have these 2 groups here, right? Okay, the 0.08, the 1.64. At this point, we don't really have enough information. Okay, and that's the process I'm trying to walk you through here. Is we don't really have enough information. So, if you go to the next page, okay, now keep in mind, I'm going to point out this number because it means something. When we had our 2 groups, when it was still with and without the additive, the difference was 0.76, right? We mixed the groups around, got one really small number, one really big number. When we go to the next page, you see a histogram here. Okay, this histogram represents, I believe it's 200 total samples. So taking and creating 2 new groups 200 different times and finding their means and differences. Okay, that's what it's looking at, is finding all of the means and differences. Now, our original difference was 0.76, right? And so about in that area right there, give or take, ignoring the squiggliness of my line and just, 0.76 is about 3/4 of the way to 1. With that in mind, okay, there's a lot of data here between -1 and 1, yes? Okay. However, there's still data between 1 and 2, 2 and 3. Okay, I mean, what have we found? We found 0.08, which would be right in there. We found 1.64, which would be closer over here. There's quite a variety going, okay? This 0.76, you guys remember a normal distribution curve? You remember that idea here? And with a normal distribution curve, 68% of the data was right here, right? Then we had 95, and then we had 99.7. Well, okay, you look at where this 0.76 is. This contains about 3/4 of the information below it, and then there's still about 1/4 of the information above it. Okay? So that means the difference is still about 1/4 of the time above 0.76. With that in mind, that's not going to, we don't have enough information. What the vocabulary they'll use is reject the null hypothesis. Okay, we do not have enough information to do that. If you recall, the null hypothesis was that the additive wasn't making a difference, right? Okay. Success. Okay. So, now, issues. These samples were just 10 each at a time, right? 10 samples isn't a lot. Okay, it's remixing those same numbers. Again, that's not going to give us a whole lot of information. So, the piece about that is we don't have enough convincing information yet. I'm going to write some information down here, but then we're going to look at additional values. Okay, we're going to double our number of values and use that as an idea. Okay, again, the idea here is looking at the statistics. How can we use the statistics to help us here? So, okay, kind of highlighting some things I explained. First of all, in this example, what did they do? They continued finding or creating the two new groups. So continue creating two new groups and finding means and differences. Okay. I also talked about how where this 0.76 lies, the differences was greater than that about a quarter of the time. So the difference of the means were greater than .76 about a quarter of the time. The small sample size was the other thing we talked about. Okay, these small samples do not give convincing evidence that the additive improves the mileage. It may have, but we don't have that convincing evidence yet.
I'm convinced.
You're convinced? Well, I'll make us convinced one way or another here in a moment. Okay, that's supposed to say, I just wrote the wrong word. I can't talk and write at the same time, can I? These small samples do not give convincing evidence. Well, officially, they don't. Small samples do not give convincing evidence the additive worked. Okay. And with that in mind, we cannot reject the null hypothesis with this data. Okay. Make sure you have the information you want. Continue creating two new groups and finding the means and differences. The difference of the means were greater than 0.76 about a quarter of the time. The small samples do not give convincing evidence the additive worked, or the additive improved the mileage. And then, so we don't have enough information to reject the null hypothesis. Now, if you're done with that, you can go down to the bottom and you can start finding those means. Okay. If you look down at the bottom, The fuel additive was tested again, resulting in the data displayed below. Use the simulation to randomly assign the data into two new groups. Find the difference of the means of the original sample and the new groups you just created. We're just going to worry about the sample here. How do they differ? Explain what additional information you need to be able to test the hypothesis from the previous example. Okay. What's different about these two new groups? There's more data values, yes? Can more data values possibly be more convincing? We're getting ready to find out. Okay, so two groups. We have without the additive, I'm going to call that group 1. With the additive, I'm going to call group 2. Are you done copying, Jay?
Yeah, go. Yeah, just go.
You're good? Okay. Do you need a pencil?
More like lead.
I don't have any lead. Might be able.
Maybe some pen.
Want to try that? I don't know. Is that the right size lead?
I think so.
Okay. Okay, guys. Well, he's getting the lead situation. Group 1. Group 2. Okay. So work to find mu1 and mu2. Tell me what they add to be, and then we'll divide, and we'll get a mean there. You guys have group 1 yet?
332.4.
Okay. They add to be 332.4. We're dividing by 10 this time. That makes easy division. 33.24. Okay. What about mu2? Mean of group 2. What do they add to be?
357.2.
He says 357.2.
See, this is just a tad more.
Divide 350. Oh, is it 357.2? I had 0.4. I just looked at my notes. Sorry, Eli, I'm going to overrule. Okay. 357.4 divided by 10 is 35.74. So that's the means. Find the differences, or the difference. So if we do the difference, mu2 minus mu1. So 35.74 minus 33.24 takes me to what? 2.5. Okay. What about that 2.5?
Big.
It's a big difference, isn't it? Okay. Now, we're not going to take the time to do it. But if we took the time to do it, we would still, because of there being more values and there being such a difference here, we would have a bigger difference than what we were seeing earlier. Okay. So, with that in mind, okay, the 2.5 is definitely greater than the difference of means in our previous samples. With this in mind, this is going to support the fact that
The additive works.
the additive is helping the mileage, right? Okay, he's a little excited about that.
Look at his help.
Told you
Now-
I convinced earlier.
Okay, with that in mind, that means the null hypothesis can be rejected. The null hypothesis was the one where we said the additive wouldn't work. And then the alternative hypothesis, that's the one where we said the additive would help, is supported. If you remember the definitions yesterday we talked about, the alternative hypothesis is the one where there's some outside force that's helping. Null hypothesis, there's unlikely any outside, force here. So this difference in gas mileage is unlikely just due to chance, but there's that outside force of the additive. Okay? So, the 2.5 is greater than difference of means previously. Quite a bit greater at that, right? For that reason, the null hypothesis can be rejected. And alternative hypothesis is supported. And then the final statement I had on mine is the difference in gas mileage is unlikely due to chance, but due to additive. Okay, so I've written down that 2.5 is greater than the difference of means previously. The null hypothesis can be rejected, and alternative hypothesis is supported. The difference in gas mileage is unlikely due to chance, but due to the additive. I should say likely due to additive. Okay, write down what you need there, and then you can start looking at Best Bet mac and cheese on the back page. Actually, if you kind of glance through there, we're going to need information about margin of error. I think it was back in 11.5. We talked about margin of error and we had some formulas. Might want to have a location on those because we're going to need margin of error formula again. I know that's been before spring break, so
Anyhow,
Skip it.
nah.
That's alright, I don't think we need to do that.
Yes, we do. Okay, you guys will have what you need on this page, yes? Okay. One last example. We're done with the fuel additive, okay? So we're going to talk about Best Bet mac and cheese and their claims. Best Bet mac and cheese reports that the average price for a box of their product is $1.45. A marketing company selects a national sample of 100 retail prices. The standard deviation of prices nationally is 20 cents, and the mean of the prices of the sample is $1.65. Does this study provide strong evidence that Best Buy's claim is false? Okay. What is Best Buy's claim?
They're the Best Buy.
Or Best Bet, sorry. Best Bet's claim, what are they saying?
Their prices is $145.
Not their price is $1.45, the average price. Okay, so Best Bet claims the average price for a box is $1.45. Okay, so this is the company that produces it. Now, with that in mind, okay, we're given some other information. But first of all, we're being asked to write a null hypothesis and an alternative hypothesis. So one last opportunity to practice here a little bit. Null and alternative. Do you remember notation? What were we using for null hypothesis? H sub O, H sub 0, right? And what were we using for alternative hypothesis? H sub A. Okay. Now, null hypothesis. Okay. You go back and look at the front when we talked about our definitions. Null hypothesis. The observed statistic in a treatment group is equal to the corresponding population parameter. and any variation is due to changes. Okay? This goes with what was their claim?
The average price is $1.45.
Okay, the average price is $1.45. Okay, so they're just saying that with no outside influence. And so average price, I'm going to use mu is equal to $1.45. Now, alternative hypothesis. And I just use mu equals $1.45 because they're not talking less than, greater than, it's just $1.45. Now, alternative hypothesis.
Alternative says that the mean is $1.65.
Well, we're not good, but remember, we're still going to use that $1.45.
Greater than.
So, could be greater than. Officially, I'm just going to put, in this case, I'm going to put it as just that it's not $1.45. Okay? And so I'm going to say mu is not $1.45. Okay? Because, and the reason I'm just saying that is we don't, I mean, yes, they have the sample, but we don't really have any indication of which way it's going to go. I mean, yes, we see what's in the sample, but we don't have indication other than that. So,
Could be less.
okay. Now, okay, so we have our null hypothesis and our alternative hypothesis. Okay, step 2. This is why I said you might want to start flipping back to 11.5. Calculate the margin of error for the new sample. 11.5. We had margin of error formulas. Yes? Are you finding them? At least I was told in the first hour was 11.5.
It is.
Okay. And I say I was told because I didn't look it up myself. Okay, with that in mind, what formulas are we finding?
To whatever standard deviation sign that sign is.
Okay, so, and do remember there's a quantitative, is that the right word?
Yeah.
And categorical. Okay, now, my hint is usually if they give you a standard deviation, they want you using that one. Okay, so we're going to use the one that is the 2 standard deviation divided by square root of n. Okay, actually I should just say 2 sigma. What does sigma stand for? Standard deviation. Did they give me that? Yeah, standard deviation is 20 cents. So on top, 2 times 0.2 divided by square root of n. What did n stand for? No?
What was the
Sample size. Did they give me a sample size?
Yes.
Of course they did. Sample size of 100. So 2 times 2/10 divided by the square root of 100. So 0.4 divided by 10. 0.4 divided by 10 is going to be 0.04. Okay. This is our margin of error. And I know it's been since before spring break. Before spring break, margin of error. Remember, a margin of error is a plus or minus range. Okay. With that in mind, okay, look at step 3. Use the sample statistic and margin of error to predict a range of reasonable values, estimating the population parameter. So, what was our sample statistic? Well, the sample was
1.65.
the 1.65. So, if you look at the sample mean plus or minus the margin of error. Okay, so sample mean plus or minus the margin of error. Well, the sample mean was $1.65. Plus or minus, what's my margin of error?
0%.
the 0.04. What is 165 plus or minus 0.04?
161, 160.
Okay. We're going to have a range here. When you do the math, you subtract, it's $1.61. If you add, it's $1.69. So this is our range of reasonable values. Okay, so when you look at that margin of error, there is a 4-cent margin of error. So that sample mean of 165 could sway 4 cents either way. With that in mind, question 4, or part 4 here. Compare the claim to the predicted interval. What was their claim?
Yeah, try to do 145.
$1.45 is the average price. What's the predicted interval?
161 or $1.61 to $1.69.
Okay, 161 to 169. What about their claim then?
It's both.
Yeah, their claim is not supported here, is it?
No.
Okay, that claim of $1.45 falls outside the range of reasonable values. And so, for that point, we have to reject their claim. We have to reject the null hypothesis. Okay? So the claim of $1.45 falls outside the range of reasonable values which that range of reasonable values was $1.61 to $1.69. And so in that matter, we must reject the null hypothesis. Okay, so the claim of $1.45 falls outside the range of reasonable values of $1.61 to $1.69. Must reject the null hypothesis. Null hypothesis was just their claim that's $1.45. Now, one more round here. Are we ready for the bottom part?
Yes.
Okay. The bottom part. Best Bet revises their claim. Reports an average retail price of $1.60 now. However, a second marketing study is also done. Sampled 300 prices for Best Bet mac and cheese, finding a mean price of $1.64. Now, it's not stated here, but we're sticking with the same standard deviation. Okay, I should have retyped that when I did that. So with that in mind, margin of error. What is the margin of error? That's going to be doing what? 2 sigma divided by square root of n. So 2, what was the standard deviation?
0.2.
0.2 divided by square root of
300.
300. I know I have it here somewhere. This is not an easy one to figure out. Bye. 11.6 is in Savas, okay?
All
right. Do the math. Grab the calculator. It's definitely a decimal. Zero point, what was it? Are you saying
3.
0.00.
002.
0.023.
I say it should be 0.023. Yes? No?
Yes, I said that's what I just said.
That's not what everyone was saying. That's why I was trying to figure out where we went astray. Okay, now,
Calculator issue, not me.
blame it on the calculator.
That's right.
Margin of error.
Zero.
This margin of error is going to be in terms of money. So let's change it to 0.02. That's what I was really trying to figure out. Like, I know it can't be 0.002 because then that's going to round to 0 cents, and I know that was a problem. So, okay. Is Best Bet's revised claim supported by this new study?
No.
No? Why not?
1.60 still falls out of the range because the range is 1.62 to 1.66.
Okay. So it doesn't ask us to, but let's find that new interval because that's part of our defense here, so to speak, or explanation. The new interval, well, we've got a new mean price here, which was $1.64 plus or minus the new margin of error, which is 0.02. Okay. $1.64 plus or minus the 2 cents is going to give you a new range of $1.62 to $1.66. Well, what was their new claim?
Still wrong.
$1.60. Okay. So, is there support by this new study? No. $1.60 is not within the range of reasonable values.
There's lies.
And not once, but twice. So no, $1.60 is not within the range of reasonable values. Okay. 11.6 is out there in Savas. That is your homework due tomorrow. Okay. We will be going into chapter review, looking at chapter test next week. And then you need to make sure you get up through 11.5 caught up as well. Okay. I know some of you were back in there yesterday. I know I have at least one email I haven't had a chance to deal with. We're back in there yesterday and updated. I did not get a chance to get back in there yet to update grades, so I will work on that. Last time I updated grades was Monday, so.